Hi viewers, this is Sri Ramulu. So today's topic is electrostatic due to a infinitely long charge distribution. So let me explain completely. Consider an infinitely long line charge of linear density lambda. So linear density means it is defined as charge per unit length. Charge per unit length is called linear density. Charge per unit area is called surface density. It is denoted by sigma. Charge per unit volume, it is denoted by rho, and it is called volume density. So linear density, surface charge density, volume charge density. So like this, three different types of densities present. So depending upon the dimension, whether it is one dimension, take lambda, two dimension, take the sigma, for three dimension, take the rho. So depending upon dimensions only we have to take. Now, as the charge distribution is linear, linear means along a straight line, linear, we construct a Gaussian, we construct a cylindrical Gaussian of radius, means it is a Gaussian cylinder. Okay, Gaussian cylinder of radius small r from and a length L as shown by the dotted line in the figure. Here, so here from axis, here from axis, right? Why? Because radius we take from the axis or from the charges only. Here the charges are nothing but axis. Why? Because they are distributed along a straight line direction. Next, all the points on the curved surface. So see here, diagrams first. It is a Gaussian surface, Gaussian cylinder, but charges are distributed along the line. So here 1 2 3, see along the line, so that is why it is a simply one dimension. In this charge density, what we take charge density as lambda. Lambda is equals to q by length. Why? Because see, length of the Gaussian cylinder is taken as L meter. The direction of the field at any point on the curved surface is normal to the line. Direction of the field at any point on the curved surface is normal to the line. Normal means perpendicular to the line, or which makes 90 degree. Normal means perpendicular. The meaning of normal here, perpendicular. So here if you observe field direction, so this side the field direction like this side also field direction like this, but actually we have to calculate the electric field at three different points: on left end, right end, and on the curved surface, on the surface of the cylinder, Gaussian cylinder. At the ends of the cylinder, E will be perpendicular to the ds, right? At the end, just now I have shown at the end side, that is either left end or right end, so that is why I have written ends, right end, left end. So at the left end or right end, if you consider the small portion here, small area whose area element is ds, ds always denoted normal to the considered area, right? Suppose if you consider this much of area, then you must show it perpendicular to the its surface, right? So ds is in this direction, but field is like this. So just now I have shown above. And at this point also consider the small area whose area element is ds in this direction, but field is like this. Angle between them is angle between them is 90 degree here, and here also 90 degree. So once again see the diagram above. See here, right end. So area is considered, and its area value is normal to the surface, that is along this direction, but field is in this direction. Angle between them is here 90 degree. Here also same thing, but at the curved surface, field direction this and the same direction of ds also. So ds and field direction are same on the curved surface, but at the end surfaces they are normal to each other, means they are perpendicular to each other. So that is why the value of phi in this direction and in this direction is 0. So that is I have shown, I will explain, see in the derivation. So total phi we have to calculate. So phi integral left side, right side on the curved surface. General formula phi is what? Simply integral e bar dot ds bar. Okay. So this value is we have to apply at the right side, left side on the curved surface. So left side, right side on the curved surface. So here these two are the vector quantities here. E dot ds, E dot ds, E dot ds are the vector quantities. So above it bar is not mentioned, but you must understand they are vector quantity and bar has kept. Now as on the both ends, see both ends, the Gaussian cylinder E is perpendicular to the axial area vector ds, right? On both ends, right end and left end, both ends are perpendicular. So that is why, hence E dot ds value is 0. Why E dot ds 0? So we know the formula. What is that formula? Integral E bar dot ds bar can be written as integral E ds cos theta. So theta value is how much? They are perpendicular, means theta value is 90 degree. So if you substitute the 90 here, cos 90 is 0. So that is why these two terms are 0. This left and right are 0. 0, 0. But only curved surface present. Along the curved surface, theta value is how much? Theta value is 0. Why? Because on the curved surface, electric field and elements are both are in the same direction. Okay, see in the diagram once again. Now see, so ds value and E value are in the same direction. So that is why here theta value is 0. So by this what we can conclude that, so here written E dot ds is written as eds cos theta, and theta value is substituted as 0. So that is why it is eds on the curved surface only. So that is why curved surface value we got eds, remaining values are 0. But eds can be written as, eds is what you know, eds means eds integral eds, bring e outside and write it is like this. It gives the total area of cylinder. Area of cylinder is what? 2 pi rl. Area of the cylinder is 2 pi rl. So that is why here 2 pi rl is written. Okay. According to Gauss, let it is equation number 1. According to Gauss law is what? Phi is equals to q by epsilon naught. So from these two equations, from equation 1 and 2, it is equation 1, it is equation 2. From 1 and 2, what we can write? Phi values are same. So that is why these two are also same, means these two are also equal. So this is equals to this is, right here it is written. Now keep e this side only, bring this bracket that side. So it become divides there, and in the division we have written it is like this. It is written as E is equals to q by 2 pi r l epsilon naught. 2 pi r l total here written. So that is why 2 pi r l epsilon naught. And one thing here, uh, 1D body, so 1D body I am going to write it is in terms of wavelength. If you write up to here, then it is also answer, so no one will reject you, so it is also answer. But in terms of lambda, it is the final one, in terms of lambda only. So here q by l is there, q by l is what, q by l is lambda, so that is why lambda is written. Okay, once again see here, q by l is where, q by l is there, q by l is lambda. So final answer in terms of lambda is what, it is E is equals lambda by 2 pi epsilon into r. So this is because this is electric field due to a line charge. Okay friends, thank you.